Close your eyes. Imagine you are a farmer in the northern prairies. You need to dry your crops, but you do not want to leave it outside because of animals. Fuel is too expensive to dry indoors. What do? The obvious answer is to harness the power of the sun. This is how the technology of the perforated plate air heating came to be. Especially in Canada, heating and cooling are a big part of the building's energy use, consuming a lot of greenhouse gases and electricity in the process. Using perforated plate air heating products such as solar walls can help put the heat on in large structure and take the heat off on those emission numbers. The solar wall and its related products, which we'll refer to as just solar wall from now on, introduces a simple concept in controlling the heat in the building. It uses 5 main components: a solar collector to absorb the sun's energy, structure that allows for an air gap between the wall and the solar collector, a fan to draw air in, a unit with dampers that controls the flow of air, and finally, ductwork that allows the air to be delivered. The solar energy heats the dark perforated plate installed on the facade of the structure. Radiation energy heats the air surrounding the plate, which then flows into the air gap. The warm air rises in the cavity and is drawn into the building by a fan, delivering convection heating into the building. The perforated solar collector works by using the properties of boundary layers, which are the layers of fluids immediately adjacent to a surface. The air surrounding the plate acts as a control volume and gains energy from solar radiation. It is then pulled through the perforations in the plate due to pressure differences between the heated boundary layer and the air gap. Properties such as perforation size and spacing can affect the rate at which air is sucked into the air gap, and a correct balance must be found to optimize the energy transfer and flow rate of the heated air for different situations. Generally, smaller and closer perforations work the best. Solar walls not only save energy by reducing heating costs, but it also surprisingly provides a cool function for the building in the summer. During summer months, when no additional heating is needed, solar walls would act as a shield by absorbing solar energy that would otherwise heat up the building facade and allow heated air in the cavity to be vented off. This is beneficial for thinner walls that are in direct contact with both the interior and exterior, such as some industrial buildings. The dampers at the intake would close the path connecting to the walls and open on the sides, allowing regular unheated fresh air to enter the HVAC system. Okay, but you as a farmer is now thinking, why do I want to use solar walls as a heating technology? Why not natural gas, and oil, or other renewable energy sources such as electricity, wind, or solar panels? Well, climate change is a heated discussion that everyone is trying to solve. Combustible fuel sources like oil produces 75 equivalent tons of CO2 per megajoule of energy, natural gas about 50 tons. These add up over the course of a year and contribute to a significant part of the planet burning. The solar wall can be a warm welcome to heating technology. It can be easily integrated into existing systems, reducing the load on furnace heating. The LBJ apartments in Cambridge, Massachusetts use a solar wall technology which produced 285 gigajoules of solar heating during winter, cutting the annual natural gas consumption by more than 100 kilowatt hours and reduced the CO2 emissions of the building by 18 tons. Okay, you're not feeling too hot about this technology since you don't know how this fits into the landscape of existing solar technologies? First and foremost, it is probably one of the simplest solar energy collection technologies. Similar systems such as a PV system that also utilizes solar energy need expensive components such as silicon cells and inverters. Or how about a boiler system that needs a pipe with running water as a heat exchanger system? A solar wall, however, only needs a wall and a fan, and it's good to go for at least 30 years, providing an efficient and immediate air heating solution for a building compared to other solar technologies. Of course, it comes with downsides as well. This system, as you probably realized, only provides heating to the building, whereas something like a PV system can generate electricity that can be used more flexibly. When compared to a solar boiler, where the heat can be stored, the heat generated by a solar wall must be used immediately after it's generated. So, you as a farmer decide to finally order the solar walls and use it to dry the crops and even to heat your home. And your buildings on the farm have never looked more stylish with those metal perforated panels. Harnessing the power of the sun and armed with your new knowledge about perforated plate heating, you are ready to tackle the solutions for heating needs for large structures like industrial buildings and apartments. Maybe you can go to the University of Waterloo for architectural engineering to learn more about building design solutions and energy transfer in AE 279.